Hi, um, hi. I'm Conrad's dad, and I think I might have stepped into something and cost him a couple of points on his homework the other day because we got engaged in working through his homework and went down a road about trapezoids, and we came to an answer for the problem that was presented, and it's like a way more complex answer than what was probably expected. And I'm hoping to show that one, that the answer works, and two, why it has to be that complex. And I know that this is probably like the most embarrassing thing a father could possibly do to a middle school age student is to like actually try to get engaged, but we had a pretty meaty conversation about trapezoids, and I'd like to kind of move that in the right direction. So the problem was, I think, if I'm reading it correctly, is to create a trapezoid that has a height of 40 feet, a perimeter of 160 feet, and an area of 1,200 square feet. So, allegedly, this seems like a very simple problem. It has some challenges. So, so the idea here is that we're going to add up all the sides and get 160, and we're going to use the area formula that if I take the sum of the bases and divide by 2 and multiply that by the height, I'm going to get 1,200. And what Conrad put down on the page after he and I did a lot of kind of number crunching here was 59 over here, 41 over there, and then it's a weird 51 minus 3 times the square root of 209 over 2 in the top, and 69 plus 3 times the square root of 209 over 2 in the bottom. And so this would be a trapezoid also that has a height of 40. That's the constraint that's going to cause the problem. And we'll kind of get into that in a second here. But first, let me justify that this is, in fact, a correct answer. So let's go after these constraints, the perimeter constraint and the area constraint. All right, so let me clear out some space here. Okay, so the perimeter should be the sum of our 4 sides, which was 59 plus 51 minus 3 radical 209 over 2 plus 69 plus 3 radical 209 over 2 plus 41. Okay, so the weird stuff is this stuff in the middle. So if I kind of parse this out, I'm going to get 51 over 2 minus 3 radical 209 over 2 plus 69 over 2 plus 3 radical 209 over 2 plus 41. This is a negative and that's a positive, so when I add these things I get 0. So I get 59 plus 51 halves plus 69 halves plus 41, which is 59 plus, let's see, 9 and 1 is 10, 11 is 120 over 2 plus 41, and then that's 59 plus 60 plus 41, which gives me, let's see, 59 and 41 is going to be 100 plus 60 is 160. So the perimeter is 160 feet. Okay, so that stays intact. Now, something to note here, because it's going to help us with the area formula, is that this is the sum of the two bases. So this is B1 plus B2. Okay, so when I took that sum, I got this, which became this, which became 120 over 2, which became 60, which means that B1 plus B2 is 60. So area is B1 plus B2 over 2 times the height. B1 plus B2 is 60 over 2 times the height, 40, which gets me 30 times 40, which is 100 or 1,200 square feet. So we've met all three constraints of the problem. We've met that the perimeter is 160 feet, the area is 1,200 square feet, and we did this with a trapezoid whose height was 40 feet. Okay, now this justifies that the answer is good, but now the question is does the answer necessarily have to be this complex? Can't we just pick four numbers that add to 160 and two bases that would also just add to 60, which would seem to think that if you could get the two bases to add to 60 and the two other sides to add to 100, we should get something to work, but it's not that simple. Okay, so what's causing the problem here is this pesky little thing called the Pythagorean theorem. And the Pythagorean theorem says that if I have a right triangle, then if this is A, B, and the long side is C, A squared plus B squared has to equal C squared. Okay, so what does this have to do with my trapezoids? Well, let's take a look at something earlier in the homework, okay? So in problem number 1 in the homework, we posit this trapezoid. Seven feet are here, 12 feet are here. The height of the trapezoid is 11 feet. The base is 15 feet. And this over here is 21 feet. And our argument is that this trapezoid actually is a mathematical fiction. It can't exist in reality. Like if you actually try to take a ruler and measure out a trapezoid this way, it doesn't actually exist. And here's the reason why. We're going to make sure that we have this altitude here. So that's a right angle. And we have another altitude here. That's a right angle, which makes this box in the middle a rectangle. So the height of that rectangle is 11. Its width is 7, which means the distance from here to here has to be 7 feet. Okay, so let's take a look. What else does this cause a problem for? So taking a look at the left here, we've got a right triangle. Okay, so we got a right triangle here. This has to obey the Pythagorean theorem. So let's just call that A for a moment. According to my Pythagorean theorem, A squared plus 11 squared has to equal 12 squared. So A squared plus 121 has to equal 144. If I subtract 121 from both sides, I get A squared is, let's see, that's 23, right? 1 from 4 is 3, 2 from 4 is 2, which means that A is the square root of 23, can't be negative. And let's see, let's get an estimate for that. All right, so I'm going to bring out calculator here. The square root of 23 is approximately 4.79, so let's call it 4.8. So A is about 4.8. Okay, so now we can play the same game with the triangle over here on the right. And the triangle over here on the right is also a height of 11, right? and we can call this b. So if we take b squared plus 11 squared, we should get 21 squared. So b squared plus 121, and we're going to need a calculator for this one too. 21 squared comes out as 441. And then we subtract the 121 from both sides. We get b squared, that's going to be 0 to 320. So b is the square root of 320. So let's figure out what that is. Let's get an estimate on that. Gets me 17.8, so almost 17.9. So this is approximately 17.9. Now we right there know something's wrong, because see, if this has to be 17.9, and then I'm going to add 7, and then I'm going to add another 4.8 to that, that has to be longer than 15. So this is not something that can actually be drawn, because otherwise we're violating the Pythagorean theorem. Like 17.9 plus 7 is 24.9. Let's see, 24.9 plus 4.8 is 8, 9, 29.7, which means that 15 would have to equal 29.7 for this trapezoid to exist, which is not really what's going to work there. So you can't just make it work. You actually have to abide by what's happening with the Pythagorean theorem with these cases. So we sunk into the problem that was presented in the paper, and we realized kind of quickly that it wasn't so much as simple of picking 4 sides that would add up to 160 and then getting it to work so that it would give me the right area. But I also had the additional constraint here, because this is going to form right triangles, that I had to meet the Pythagorean theorem 2 times. And we actually kind of did some serious work to backfit that, which is where we got that strange answer of 51 minus 3 times the radical 209 over 2, and 69 minus 3 radical 2 over 9, radical 209 over 2. And this is a case that actually meets all 3 of those constraints, with a perimeter of 160, an area of 1200, and holds the height at 40 without violating the Pythagorean theorem. So I hope that we could take this in good fun, and that maybe we could see this as an awesome opportunity for Conrad to learn a little bit about math through both of us. And as a father, I'm pleading that maybe I got a little bit too far into it, but I don't want to cost him any points in his math class or anything like that. So I hope that I haven't embarrassed him too badly by doing this. Thank you.